Welcome back. Today we are looking at this question using Michaelis Menten's equation. Show that Kn is equal to substrate concentration. Show that Kn is equal to substrate concentration. This question is coming from rate of reaction or reaction velocity. Reaction velocity or rate of reaction is a way of measuring how enzyme produces products. As the concentration of enzyme increases, the rate of chemical reaction or reaction velocity will keep on increasing until it gets to its maximum, known as Vmax. At this point, all the enzymes will be saturated rather. Then any further increase in substrate will no longer yield additional velocity to that reaction. That means the Vmax is that particular spot by which there will be no increase in rate of chemical reaction, even though substrate is increased. Now, Vmax, the concentration of substrate that will give half of velocity maximum, that is Vmax, is known as Michaelis-Menten constant. That's Michaelis constant, Km. Now, this graph will explain better. This graph is the graph of velocity maximum versus substrate concentration. This is velocity maximum, this is substrate concentration. The maximum velocity of this reaction here is 8. So the half of this maximum velocity, half of this Vmax here is somewhere around 4. Any concentration of substrate that corresponds to half of Vmax is known as Km. That is Michaelis constant. So if you trace this to here, you will see that this is where the substrate concentration matches with half of Vmax. That means that this is the Km of this reaction, according to this graph. So this is Michaelis constant for this reaction. Now, back to the question. The question is asking us to use Michaelis-Menten's equation to show that Km is equal to substrate concentration. Now, let's recall that Michaelis equation says that from Michaelis equation, we have V to be equal to V max substrate concentration all over Kn plus substrate concentration. So this is Michaelis equation. This is Michaelis equation. Now let us assume, remember that the half of V max from this, which is the Km, if we substitute half of V max into this equation, to substitute V by half of Vmax, this equation will now become half of Vmax. To represent V, the equation will now become Vmax substrate concentration all over Km plus substrate concentration. Now, if we make Km subject of the formula, we'll now have Km. If we make Km plus substrate concentration subject of the formula, we now have Km plus substrate concentration will be equal to, if we're making this, we now have 2 Vmax, 2 V max substrate concentration all over Vmax. All over Vmax. So at this point, we have Vmax at the numerator. We also have Vmax at the denominator. So we can actually cancel them like this. So if we cancel, this equation will now become Km plus substrate concentration equal to 2 substrate concentration, 2S. So at this point, Km plus substrate concentration is equal to 2 substrate concentration. Now, we are looking for Km because they say we should show that Km is equal to. So let's find Km. Km will now be equal to, if you are bringing this to this, it will now be That means this concentration will be thrown to this place. This will now be 2 substrate concentration minus substrate concentration. So at this point, we have Km equal to 2 substrate concentration minus substrate concentration. So 2S minus S is 1S. That means that Km will be equal to 1S. 2S minus S is equal to 1S, which is substrate concentration. So this is the final answer. Now, if you juxtapose this final answer to the question, you will see that we are correct. Because the question says we should use Michaelis-Menten's equation to show that Km is equal to substrate concentration. This is it. Km equal to substrate concentration. So for correction, commendation, and support, please like the video, put it on the comment section, share, and all that. Thank you so much. Now have fun now. That's what we do more, so much more.